Ba-da-dum. Okay, so we're looking at page 69 in your math book, number 4. We're going to compare the graphs and algebraic rules for the two paint mixtures and talk about some similarities and differences. Okay, similarities and differences. So let's take a minute to look at this. Well, let's see. We have green paint mix number 1 and green paint mix number 2. And you know what? While we're doing that, let's do this. Green, there we are. Green paint mix number 1 and green paint mix number 2. Now, on both of these graphs, I want you to notice that on the y-axis, we have the cups of yellow paint. On both of them, that's the same. On the x-axis, we're talking about the cups of blue paint. So that's something that is similar, right? I want you to also notice that the lines that run through both of these graphs are straight lines, right? Straight lines, they're both straight. And something else you need to notice about these two lines also is that they both pass through the origin. They go through 0, 0, the origin. And so that right away, because they're straight and they pass through the origin, that tells you right there, right now, that these lines represent proportional relationships. Anytime you look at a graph, you can see there is a proportional relationship. Now, something else I want you to notice is that in this case, the equation for this first line is y equals 2x. So that means that for every cup of yellow paint, to find out how much yellow paint you need, you have to take how much blue paint and multiply by 2. So if you have 1 cup of blue paint, you need 2 cups of yellow. If you have 2 cups of blue paint, multiply that times 2, you need 4 cups of yellow. If you have 3 cups of blue paint, then you need 6 cups of yellow. So it's a proportional relationship. That relationship between yellow and blue never changes. 6 divided by 3 is 2. 4 divided by 2 is 2. 1 divided by 2 is 2. So our constant of proportionality for this one is 2. That's the constant of proportionality. 6 divided by 3 is 2. 4 divided by 2 is 2. 2 divided by 1 is 2. So we can see right away that the constant of proportionality is 2 when we divide our y by our x. Always equals that constant. Okay. Now, on our other line, the blue line, we have y equals 3x. And you can see when we divide y by x, we're going to get our constant. But in this case, it's 3 divided by 1, and that gives us 3. And 6 divided by 2 also is 3. And 9 divided by 3, also 3. So our constant is 3. And so that's why when it is written like this, y equals 3x, that would be y equals kx. That k is 3. Y equals 3x. All right. Now, there is a definite difference between these graphs that I want you to see. The red line is not as steep as the blue line. Now, if these were hills that you had to climb, the red line would definitely be easier to climb because it is less steep. The blue line would be harder to climb because it is more steep. And that's because when you look at the constant of proportionality, this one is 2 and the blue line is 3. The higher the value of the constant of proportionality, the steeper the line is going to be on your graph. Okay. The higher the constant, the steeper the graph. Oh, I like that. I'm going to write that down. The higher the K, the constant, the steeper the line is going to be. Okay? All right. So I don't see any question marks in the chat. So far, so good. So there are lots of similarities and some differences. They're both a straight line that passed through the origin. So they are both proportional, but their constant of proportionality is different. The red line, the constant of proportionality is 2. The blue line, the constant of proportionality is 3, which of course causes the higher the constant, the steeper the line. Okay, well let's move on then to question number 5 on page 70. In a proportion relationship, the constant of proportionality, which we've been talking about a lot already, is the numerical portion of the unit rate. Okay, the unit rate, the numerical portion of the unit rate. Now you have to remember what a unit rate is. So remember when we had, okay, so when you've got, so let's say you had 6 cups of yellow paint for 3 cups of blue paint. All right. And we wanted to make that into a unit rate. Well, that means we have to have 1 in the denominator. So 3 divided by 3 is 1. 6 divided by 3 is 2. And so the unit rate right here, this number right here, that is our constant of proportionality. Because when you divide the y by the x, you get that constant of proportionality. Now, the really cool thing that I want you to see here, and this is hugely important when it comes to recognizing proportional relationships, gigantically important here, okay? Question A says, how can you identify the constant of proportionality in a graph? All right. Well, when you look at the graph, here's how you know. You go until you find x is 1. So you say, when x equals 1, comma, the COP, the constant of proportionality, is the y value. Okay, so looking here, we go, all right, let me change my highlighter color here. Well, that wasn't what I wanted. Okay, when we look, we find x to be 1, right? There's 1. We go up. How much is our y value? Well, our y value is 2. So this right here, the 2, when x is 1, that is our constant of proportionality, the 2. And in the second graph, when you look at the second graph, when x is 1, right? X is 1, go up and over, and you can find what your y value is. In this case, the y is 3, and that's our constant of proportionality. So the thing you have to remember when you're looking at a graph, when x is 1, the constant of proportionality is the y value that goes with. So it's when x is 1, it's that y value that goes with. All right. Now, moving on a little bit further, how can you identify the constant proportionality in an algebraic rule? Well, here are our algebraic rules. So, can you find the constant of proportionality there? Of course you can. Look, it's right here. It's the number that's being multiplied by x. But that's got a fancy mathematical term for it, and it is called the coefficient. The coefficient, it's the number that is multiplied by x. So in an algebraic rule, the coefficient And if you have to remember what a coefficient is, you might want to write it off to the side. That's the number that is multiplied by a variable. The coefficient of x is the COP, the constant of proportionality. So it's really easy to see. Look, there it is. Look, there it is. It's the number that is multiplied by x. The coefficient of x is your constant of proportionality. It's just that easy to find in an algebraic rule. Now, remember when we were dealing with tables and we had a table of values? We had x, y values, x and y. And if this was 1, this was 2, this was 2, this was 4, this is 3, this was 6. If this was 10, then this was 20. In order to find the constant of proportionality in a table, you take the y value and divide by the x value. And that will always give you your constant, the COP. So how can you identify the constant of proportionality in a table? You divide your y by your x. Y divided by x gives you your k, or otherwise known as the constant of proportionality. It's that easy. But remember, it's not x divided by y, it's the y divided by the x. Your output divided by your input. Any questions so far? Looking good? Remember, if you have a question, all you must do is type a question mark into the chat, and I will address your question. All right, well, let's take a look at number 6 here then. In green paint mixture number 1, the ratio of blue to yellow is 1 to 2 and has 2 related rates. Explore the unit rate of yellow paint per 1 unit of blue by completing the table, equation, and graph. All right, so we're gonna walk through this. Now, here's how we go. Now, this is taking the opposite of what we've been doing. Now we're going to base the blue paint that we have on the amount of yellow paint that we have. So if we look at certain ones here that are filled in already, like say this one and to this one, how do I take 2? Now, see, that's saying that yellow paint is our input. If I input 2 and my output is 1, what is the rule? What's happening to get from 2 to 1? How do I get from 2 to 1? So 2 times something, because I'm going to have to multiply it by something. 2 times what makes 1? Well, it's going to be 1/2. 2 times 1/2 makes 1. 2 times 0.5. 2 divided by 2. I'm sorry, yeah, 2 divided by 2. 2 divided by 2, that makes 1, right? But remember what division is? It's multiplying by the reciprocal, so I am multiplying by 1/2 to make 1. Now, does that work for this one that was also given to us? 4. Is 4 times 1/2 2? Absolutely it is. So that means, oh, and let's look at this other one. 6 times 1/2. That equals 3, doesn't it? 6 times 1/2, 6 divided by 2. All right. So if I have 1 cup of yellow paint, then that would be 1 times 1/2, which would be 1/2. And 3 times 1/2. Well, let's see, 3 times 1/2 would be 3/2. 4 times 1/2, 5 times 1/2 will be 5/2, or 2.5, same thing. That equals 1.5. This would be 2.5. Okay, but what about x? X, times 1/2? What is x times 1/2? You know what? I should turn that around because x times 1/2, is gonna be 1/2 x. So that y, oh, you know what? I should have left that alone. Just a second. I'm going to put it back just the way it was. I apologize. I got over anxious. X times 1/2. So over here, then in this case, y, the amount of blue paint that we use will be 1/2 times x. There we go. Y equals 1/2 x. There, we have found, we've written our rule to find this simply by taking 1 over here. And how do we get that number there? How do we take this x value and make that y value? Using multiplication. And then taking that same rule and applying it to every scenario in the same situation. All right, so 2 equals 1/2 x. Now, the next part of this is pretty easy. Let's see, is this going to give me the right size dot that I want? Yes, but probably the wrong color. Yeah, let's use light green. That'll be nice. Okay, so using this graph then, right? We can graph the data from the table. For 1, we're going to use 1 cup of yellow paint. We're going to use 1/2 cup of blue, all right? For 2 cups, we're going to use 1 of blue. Let's see, I'm going to skip and go from 4. That'll be easier. If I go 4, 2, there we go. And go over to 6. 6 would be 3. And I'm willing to bet that 8 would be 4 because look, now if I go back and I make this a straight line, then I can connect from my origin right through all of these dots. Pretty darn close. My dots were a little bit off, but that's okay. Now see, I completed the table by finding the process and sticking to it. I was able to create my rule, and I was able to graph it. And right here, when x is 1, how much is y? Well, y was 1/2. My constant proportionality, the 1/2. In my equation, it's 1/2. And in my table, when I take any one of my y values and I divide by x, I always get 1/2 every time. Constant of proportionality. Well, the rest of this will be your assignment. I believe there's only one segment left here, and it's question 7, broken into 3 parts, and that'll be yours to figure out on your own. Stop the recording.